Welcome to InfoStream YouTube channel. So in this video, let's discuss about the AMIN code. So this is the second problem I am discussing. The part 1 video link I will give in the description. So we are using only 4 steps to solve the AMIN code problem. Very easy. So here if you see, this is the given example. For this we must write the AMIN code. So while writing the AMIN code for this one, if you see here, in the given frame, we are having only 4 bits. 1, 2, 3, 4. So let's write m value is equal to 4. So what m represent? M represents the number of bits in the given frame. Now first step is to generate the parity bit. Now if we want to generate the parity bit, we need the value of m, we got it here, but we don't know the value of r. So this is the formula used to generate the how many number of parity bits are there in the problem. So we don't know the value of r. So we must do the trial and error method. The r value must be greater than or equal to 1. So let's take the first condition. Let r value is equal to 1. If I put r value is equal to 1, 2 power 1 greater than or equal to, what is m value? M value is 4 plus r value 1 plus 1. Now if I write 2 power 1 will be 2 greater than or equal to 4 plus 1 is 5, 5 plus 1 is 6. Whether 2 is greater than or equal to 6? No. So what I will be doing? I will be changing the value of r from 1 to 2. 2 power 2 greater than or equal to m plus r value is 2 plus 1. So now let's check. 2 power 2 is 4 greater than or equal to 4 plus 2 is 6, 6 plus 1 will be 7. Whether 4 is greater than or equal to 7? No. So let's move and change the value of r from 2 to 3. So 2 power 3 means 8. 2 2s are 4, 4 2s are 8. Next if 4 plus 3 plus 1. 4 plus 3 is 7. 7 plus 1 is 8. So if you see here, 8 is greater than or equal to 8. So this condition is satisfied. So now this situation is satisfied. So we can conclude that r is equal to 3. So total 4 number of bits were given in the frame. With that we will be adding 3 parity bit to design the AMIN code. 3 parity bit. Now this AMIN code will be acting as dual. That is, it will be acting as the error corrector also and error detector also. So it will be doing detection and correction, both the works. Now 4 bits we have already here. But what are the 3 parity bits? We need to know. So since I am having only 3 parity bits, I must represent it using the 2 powers. 2 power 0, 2 power 1, 2 power 2. I must start from 2 power 0 itself. Since 3 parity bits, so only 3 conditions I took. 2 power 0, 1, 2. If it was 4 means 2 power 3 will be added. Now write the values. 2 power 0 means 1, 2 power 1 means 2 and 2 power 2 means 4. So the 3 parity bits which will be added for the bits given in the string will be in the places of first place, second place and fourth place. Now let's find the value of the unknown parity bits. So how to find means, how many numbers are there? 4 plus 3 bits. So start from 1. 1, 2, 3, 4, 5, 6, 7. Right from right hand side towards left hand side. Now where and all the parity bits are there? First, second and fourth position. So let me call it as P1, P2, P3. So P1 is at the first position, P2 is at the second position, P4 is at the third position. That is parity bit 1, parity bit 2, parity bit 3. Now we know the other 4 bits. What are the other 4 bits? 0, 0, 1, 1. Now while writing 0, 0, 1, 1, write from left hand side towards right hand side. 0, 0, 1, 1 like this. So while writing the parity bits, right side to left side, while writing the normal bits from left side to right side. Now over. Now if I want to find the value of P3, P2 and P1, we will be finding the possible combination. So here we are having 3 inputs. So 3 inputs means 2 power 3. 8 combinations will be there. What are the 8 combinations? Let's start from 0. 1, 2, 3, 4, 5, 6, 7. So 0 to 7 means total 8 combinations. So what are the inputs we are using? P1, next is P2, and the third one is P3. So now let's write the possible combination. What will be the possible combination? So 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. So if you have studied the digital electronics, you will be knowing the short trick to write the possible combination for the three inputs. Three inputs means 4041, 2021, 2021 alternatively, then 01, 01, 01, 01 alternatively. Now what you must do is take P1 separately, P2 separately and P3 separately and write the values which are having 1. Now if you see the P1, where and all 1 is there? At the first position, third, fifth and 7th. So write 1, 3, 5, 7. Next P2. P2 is having 1 at second, third, sixth, 7th. Second, third, sixth, 7th. Next P3. 4, 5, 6, 7. 4, 5, 6, 7. Now, what and all the values are in the initial table, just copy them. What is in the first position? P1. What is in the third position? 1. Fifth position? 1. Seventh position? 0. What is in the second position? P2. Third position 1. Sixth position 0. Seventh position 0. Fourth position we are having P3. Fifth position 1. Sixth position 0. Seventh position 0. Now if we want to proceed with the problem, we can proceed in two ways. One using the odd parity and another one using the even parity. So even parity will be very easy. That is, how many number of zeros will be there, that many number of 1 must be there. So you can balance each other and it will be even. So if you see here in this combination, 2 1 is there but only 1 0 is there. So to balance that one, I will assign P1 value as 0. Now if you see 2 0 2 1. Next, if you come to P2, only 1 1 is there but 2 zeros are there. I want to balance, so I will assign P2 value as 1. So 2 1 2 0. Next, for P3, 1 1 is there and other 2 are there. So to balance, I will write P3 value as 1. Now if you see here, we have balanced all of them, and these three initial steps which we done here are from the sender side when we are sending a message to the receiver. So the last step is at the receiver side. Here there will be a checking whether the message sent from the sender is correctly received at the receiver side or not. How means? So let's write the P1, P2, P3 combinations. So P1, P2 and P3. So what are the P1 combinations? 0 1 1 0. 0 1 1 0. Next P2 1 1 0 0. P3 1 1 0 0. So these are received at the receiver side. At the receiver side there will be a checking. How means? Number of zeros must be equal to number of ones. Number of zeros must be equal to number of ones. If you see here 2 0 2 1, 2 0 2 1, 2 0 2 1, 2 0 2 1. So all the condition, the number of zeros are equal to number of ones and they are even. What happens is, it will assign the value as 0 at the last end. When the receiver side will be assigned with the 0 as the last answer, so you can conclude that the message is accepted at the receiver side and it is not having any error in it. That is, error is detected or corrected, or it may not have any error in this problem and it has been accepted at the receiver side since we got the 0 as the final answer. So what you did? First generate the parity bit while satisfying this condition. Next, total number of bits and assign the spaces where the parity bits will be there. So parity bits P1, P2, P3. 3 parity bits. So 2 power 3, 8 combinations you will be writing, and where and all 1 will be there, you will be assigning the values see in this table. Now to satisfy the condition whether it may be even or odd parity, you will be using the even parity to solve this problem. So equal number of zeros and ones must be there. So you will satisfy the condition and at the receiver side you will assign the value as 0. You will only assign in the problem. In the reality the machine will assign the value, but in the problem you will only assign the value as 0. Then you can prove that it is accepted at the receiver side and there is no error detected. So if you have any doubt regarding this topic, please do comment below. I will clarify it. And if you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related topics. Thank you.